guys. I just want to do a quick little just recap from this week and do one or two more examples on transformations for you guys. Remember that a transformation is an operation that maps a geometric figure, the preimage, onto the image. The preimage is the original image and the image is the new figure. The most important thing to remember about this is that they are always congruent, meaning that they stay the same size and the same shape. The size and the shape does not change, it's just the direction or where it is on the graph, okay? So I'll just do a couple quick examples for you guys, a little bit extra practice that we didn't get to in class. I'm sorry, this one on a translation. It says a triangle or rectangle ABCD is a parallelogram. Use the arrow notation to write a rule that describes the translation of ABCD to A prime, B prime, C prime, D prime. So basically what happened is we went from the black parallelogram ABCD to the blue one, A prime, B prime, C prime, and D prime. The little prime symbol means that this is the new one, okay? That's what that means, that's the new one, the new image. So when we say arrow notation, all that means is they want us to write the rule is that we had X and Y, our values X and Y, and what are we doing to X and Y to get our new image? Well, the best way to figure out what we're doing to each point is pick a point. So I'm gonna pick A and look and see, okay, what did I do to get from A to A prime? Well, it looks like I went left and I went down. So how many did I go left? I went left 1, 2, 3, 4, 5 times. So what that is that that's going to be X plus a -5 because I went left 5 times. That's X plus a -5. I went down 1 time. So that's going to be Y plus a -1. Or if you want to write it as X minus 5, Y minus 1, that is fine as well. Okay, so what we're doing here is our rule is each point we took 5 away and we from the X value and 1 away from the Y, and that's how we translated this parallelogram. We slid it left and down. We do the same thing for this one. We want to write a rule, so we have X and Y are our points, and what do we do to X and Y? Well, we started at P and now I'm at P prime. Looks like I went up and right. So I went up twice. So to my vertical change, I added 2. And my horizontal change, I went right 1, 2, 3, 4, 5, 6. So I went right 6 times. So that is the rule that shows the translation. So remember, a translation is a slide. And a translation shifts and slides our figure all over the graph, but it doesn't turn it or flip it, okay? So the flipping comes when we get to our reflections. So let's look at our reflections together. We said a reflection is a mirror image of the original figure. We did some examples. I wanted to do maybe one more with you guys, 1 or 2 more. I don't know if we did this one in class or not, but we've got, I'll do this. I don't think we did this one. We have JKL and we want to reflect it across the Y-axis. So that means I'm reflecting it across the Y-axis right here. So every point should be equal distance from that line of reflection because this is my line of reflection. So we notice that L is 4 to the right. So L prime is going to be 1, 2, 3, 4 to the left. Okay. J is 2 to the left or 1 to the left. So J prime is going to be 1 to the right. K is 2 to the left. K prime is going to be 2 to the right. And there is my reflected image. It's a mirror image. All the points are equal distance from the line of symmetry or the line of reflection. And if I was to list my points, so J was -1, 1. If we reflect over the Y-axis, the X value changes. So J prime was +1, 1. L was 4, 2. So L prime was -4, +2. K was 2, -2. So K prime is -2, -2. So notice because I reflect it over the y-axis, all of my signs of x are what changed, okay? If you're reflecting over the x-axis, the signs of y will change. So remember the reflections, it's our mirror image. The only other type of reflection we might see is occasionally you will see a reflection that is not along the x or the y-axis. And in that case, you just need to look and see, well, where is the middle of these two pictures? What is exactly in the middle? So if I'm looking at this one, I see that y is not the line of reflection, this line is. So what is this line? Well, I went over 1 on the x-axis. So this is the line x equals 1. So it's a reflection of the line x equals 1. And again, it's pretty easy. We just make sure all points are equal distance from this line, which they are, okay? For example, this one right here, the line of reflection, the middle is right here. That's not the x-axis, it's not the y-axis, so it's a line, and it's a line y equals -1, because I went down 1 on the y-axis, okay? So sometimes if there's line of reflection is not one of the axes, you just need to pay really close attention and make sure that you're in the middle of the two pictures, and just notice that like everything should be equal distance from that line. And lastly, I want to do just an example or two on rotations, because we didn't get to any examples in class. We talked about the rules and switching the signs and switching the places, but I want to actually do the rotation. So for example, if I asked you to rotate rectangle ABCD around the origin, how would I do that? Some people can just visualize this. I am not one of those people, so I use my rules. So my rule says if it's 90 degrees, I take all my x and y values, I switch their place, and I'm going to change the sign of whatever x is. So I'm going to start with A. A is at the point 1, 2. So A prime, I'm going to switch their places, and then I'm going to change the sign of whatever x was. So x was +1 here. So over here, it's going to become -1. So I know A prime is at 2, -1. Okay. B is at 0. No, it's not 0. It's at 1, 0. B is at 1, 0. So B prime, we switch their places and we change the sign of 1 because that's what the x value was. So instead of +1, it's at 0, -1. So 0, -1 is right here. Here's B prime. C was at 5, 0. So C prime are going to switch their places and it's going to become 0, -5. So the +5 became a -5. So that's where C prime is. So 0, -5. And then D was 5, 2. D prime is going to be 2, 5. Make the 5 negative. Okay? So that's where that point's going to be. And that is my 90-degree rotation. So some of you guys can just visualize that. Again, I'm not one of those people. I follow the rule. I like the rule. It makes it simple. What if I ask for 180-degree rotation? So this one, the first thing we gotta do is you gotta plot the original points. So x is at 3, -1. And we always, always, always label our points. Y is at 5, -1, 2, 3, 4. And z is at 1, -1, 2, 3, 4, 5. And here is my figure. Here's my triangle. Now, I want to rotate it 180 degrees. So the rule for 180 degrees is we just change the sign of x and y. We don't move them around, we just change their sign. So if x was 3, -1, x prime will be -3, +1. If y was 5, -4, y prime is going to be -5, +4. If z is 1, -5, z prime will be -1, +5. It's that easy. So -3, 1 is my x prime. Negative 1, 2, 3, 4, 5, up 1, 2, 3, 4 is my y prime, and negative 1 up 1, 2, 3, 4, 5 is my z prime. There is my 180-degree rotation. So I turned it twice. It's really a full 180. We talked about that in class with that TikTok video. It's a full 180. It's turned around. It's not turned all the way back around. It's turned directly in the opposite direction. That's how we do rotation. The only other thing you might see with rotation, I want to make sure everyone sees this, is sometimes it's going to tell you to do it counterclockwise. It's going to say counterclockwise. So counterclockwise is just like going the opposite direction. So I'll show you an example of this really quickly. So here's your circle, and we talked about in our circle that our circle we split up into 4 90-degree quadrants because it's 360 degrees, right? So if we're going clockwise, the way of a clock, this is clockwise, we have 90, so this is a 90-degree rotation. Let me write it right there. Oh, my circle went away. Hold on. There we go. All right, we have a 90-degree rotation, we have 180 degrees, and we have 270 degrees if we're going clockwise. Going counterclockwise just means we're going the opposite way. We're going this way. So here's the cool thing. If you know clockwise, you know counterclockwise. So counterclockwise, 90 degrees is the same thing as clockwise 270. Counterclockwise 180 is the same thing as 180. So these are the same. We like these. It's like the song, full 180. Counterclockwise 270 is the same thing as clockwise 90. So we can always do that. For example, if I said, all right, point A is at 7:11. Okay, and I said do counterclockwise 90 degrees. Well, you know counterclockwise 90 degrees right here is the same as 270 clockwise, okay? And we know the rule for 270 clockwise, we take x and y, we switch their places, and we change the sign of y. So it's the same rule. So all I do is I say, okay, well then A prime, I'm gonna switch x and y. All right, y was positive 11, now it's going to become negative 11. Now it's going to become negative 11. So our counterclockwise would be negative 11, 7. If I want to, all right, point B is 2, negative 4. And I said do counterclockwise 180 degrees. You're like, oh, that's the easy one. That's the same as 180 clockwise. All we do is our rule is we switch the signs. So it's going to be B prime will be -2, +4. Okay, that's all we have to do. You might want to write these down, and it's just the opposite. So basically, it's the same thing. 90 degrees counterclockwise is the same thing as 270 degrees clockwise. So that's x, y becomes -yx. 80 degrees counterclockwise is the same thing as 80 degrees clockwise. Same thing. So xy just becomes -x, -y. And 270 degrees counterclockwise is the same thing as 90 degrees clockwise, which is our first rule we learned, which is xy. We switch their places, we change the sign of x. So that's just a quick review on all the different types of transformations we've talked about. You need to be familiar with all of them. I hope this helped, and I hope you guys watch it and listen and learn.